right, so this first quiz is very much a task of, do you know what it's asking and do you know what all this notation means? One of the things you're tested on through College Board that's different from when I went to actual college and took this, I didn't have AP, I took it in college, is we didn't really have to have great notational fluency and we didn't have to really write it really well, we just had to be able to do it. The problems were generally more difficult than the AP, but we didn't really have to understand what we were doing. So AP is a little bit more, do you really understand what this means to take a derivative, not just take a bunch of hard derivatives? So that's kind of what this is. Do you understand what this situation is? That we have some function in blue here, and that I'm going to do in red, right? And we've taken 2 points on it that we're calling P and Q. And we're actually working with the derivative. This right here is the slope of the tangent line, correct? This right here is the change in y over the change in x. See how it went from a to a plus h. A is a number in this case. This is the derivative at a. It's the slope of the tangent line at point P. Does that make sense? What is this notation for, somebody? What's that? No limit, just a change in y over change in x. Quinn, can you tell me what this is notation for?
The slope of the secant.
That's the slope of the secant line. Yeah, oops. I wish I hadn't made it so thick, but I'm not going to erase it. And we scooted over h. So as h becomes, again, closer and closer and closer to 0, we'll land on that tangent line there. So let's go over here. What is this? F of is a y value. So I like to think the y value at a plus h. So Alex, what did you choose for letter 1? I. Let's go take a look at the choices. I can't even see them. What is that? It's the y value at a plus h. So it's the y value at which point? Q. You should have chosen the y value at point Q. Where is that? B. Is that what you had? Perfect. This right here is the y at a plus h, how high it is, right? Minus the y at a. So it's really the difference in the y values or the change in y. Right, Hayden? What'd you pick for that one? Don't worry if you're wrong, we'll just publicly humiliate you. It works wonders. I don't think so. The y value at point P would be the f of a. Yep. So someone else got a new one. That's okay. We'll let you live.
D.
It is D. Yeah, it's the vertical distance between the two y values. Now, if this was written in Algebra 1 notation and it said y2 minus y1, you'd be going, it's a change in y, right? But this is a little different notational fluency to it. So that's why it's a really good exercise today. What is this? You already told me, because that was right here. And Quinn said it's the slope of the secant line, but it's not at a point. You can't have a secant line at a point. A secant line connects points. Where is that? Thank you. I'm sorry. This is my first hour doing this, so I'm like, you help me find them. All right, this is the most important one, right? It's the derivative at A, which is at point P. So it's the slope of the tangent line at point P, or the instantaneous rate of change at point P. And let's see how they worded it. It's actually kind of good that I don't even know. Here it is, I. Did anyone get all 4 of those? Good. About half of them in here did. So that's great. That should have been a struggle. Next up, I've got to make sure, I hope I hit record. Oh, thank God. Okay. I didn't see my timer. It was behind the thing. Okay. I did a whole one with the A group last week, like one of the 20-minute ones, and I hadn't pressed record, so while they were working, I had to come up and do it all over again for you guys. I was like, no! All right. So what is this guy right here? I said, you guys are listening so well, too. I love it. I do like my B group. I just don't know you very well. All right, this is that. What does this little triangle X mean for those of you who watch the notes? Delta X, change in X. And the reason I have that is, again, you need to have notational fluency. Some books, teachers, professors use H. Some use delta x. So I pepper them both through so that if you go on and somebody calls it delta x, you're not like, what? That's your h. All right, so this is f of x plus h. I always find that first, by the way. And I see, what are they doing to it? Are they taking the sign of it? Are they cubing it? Are they natural logging it? They're not. What are we doing with the x plus h? Squaring it. This is f of x equals x squared. X plus h got plugged in and squared, right? At a specific spot, at x equals 1. So let's see if you thought this through correct, Sam. It's not x squared, okay? Because it's, what does it say to find? Determine f of x. Well, f of x is x squared, right? So no, no. And at what point, or at what would we call the c value? At 1. Yes, how'd you do?
I got that.
Good. All right, I really want you to be able to, you don't have to do it anymore. But even on your test that I give you sometime, either late next week, like Friday or the week after, I don't know yet, I'll have a couple of those where you just need to spot it. I won't make you do it by hand because we know the derivative of x squared is 2x, right? So the next one, it says in the, I thought this one's kind of tricky. It says in the figure at the right, the graph of f is shown. So this is f, it's kind of, it looks sort of natural logarithmic. And we are hopping on at 1, it looks like. So let's go 1 over. There's 1 f of 1. And then it looks like at a 4th. So here's a 4th f of 1/4. Do you see how I got those points? Right? So the first one, let's go talk about in order. What is this notation for if we did f of 1 minus f of a 4th over 1 minus a 4th? Classes are fogging up, starting now. What is that? Go ahead and tell me, Quinn. Because you told me on the last one. It's the y values, right? Over change in x values. Right, Lainey? It's the slope of the what? Secant line. So you're thinking in your head the slope of this line for that one. I don't know what it is, but it's pretty steep, right? Next, what is this one notation for? The derivative, right? At what point? 1. So it's the slope of the tangent line at 1. You guys are doing great. I'm hoping today's helping. We're not really taking notes. We're just making sure. So which one's bigger now? Yeah, okay, so you can kind of see this. We're talking about slopes. This one is steeper than that one. We good? What is this? It's cheating, because that's kind of f of 2.
It's still horizontal.
Yeah, it's very small, right? Because this is here, this is here. It's hardly going up at all. That's way smaller than the other ones. So what did it say? Smallest to largest? It's going to go there. 3, 2, 1. I'm curious if anyone got that right, because that was, oh my God, almost all of them in here did. Unless they're lying to me. I don't know if they're liars yet. I don't know them very well. But all right, next one. I thought this would go way worse, Lainey. Good. It means you guys are watching your notes, I think, and being authentic and not copying my keys. I love it. All right, so let f of x equal the square root of x plus 2. Which of the following gives the correct limit definition of the derivative? At x equals 6. That's the limit as x approaches 6, right? Down to those two, of f of x plus, f of x minus f of 6 over x minus 6. Here's f of x minus x. Oh, they're almost good. The only thing off is the f of 6. What is f of 6? Is it 2 root 2 or is it 6? 2 root 2. How many of you got that one? Oh my God, they all did. Unless they're lying. I don't know. Are you lying, Cam?
No.
Okay. And in the notes from last week, when you weren't here, you guys, A group was, but we talked about whether a function's differentiable. We said there's 3 places at which it's not, right? Discontinuities, sharp corners or cusps, and vertical tangent lines. Those are all no-go. Can't find slopes there. It says the function at the right is differentiable, so we want it to be differential, which basically means loosely, it's smooth and roly-poly there. Okay, so where, at which value is it smooth and roly-poly? 2. Done. Okay, how'd we do? Good. That was very theoretical. Like, you really didn't write much down is my guess, right? The next one, which we're not even gonna pre-do, the next one is, not that, here it is. Power rule and equations for tangent lines. So this one is mechanical. Can you use the power rule? Oh, by the way, I'll stop this video. So you guys at home, the next one I'm not going to make a video for. I have a very detailed key.